So, the content of our video presentation is Introduction, Methodology, Result and Interpretation, and Conclusion. The purpose of the study is about the relationship between the gross rating point of television advertisement and the number of sales over 16 years in the prime TV broadcast network. The objective is to determine the relationship between the gross rating point of television advertisement and the number of sales over 16 years in the prime TV broadcast network. The next one is to find the skewness of the two variables between the gross rating point of television advertisement and the number of sales over 16 years in the prime TV broadcast network. And the last one is to determine the measure of tendency, measure of dispersion, measure of position, and measure of range of the variables. The next one is significance of study. The significance of the study is to identify the amount of sales based on the gross rating of the television advertisement in the prime TV broadcast network over 16 years period that are used to analyze and predict the investment. Based on this study, it will be helpful to contribute to our knowledge of media consumption habits that can make an impact of advertising on society and to make more investors invest so that the company profit will rise up even more.
Next, we are moving on to the second part, which is the methodology. In this methodology, there is 4 elements that we are focusing on, which are the data description, the histogram graph, the frequency table, and the scatter plots. Okay, from these data descriptions, the main objective of the table is to classify the main objective that we are focusing on, to determine the variable, the type of variable, the level of measurement, and the method. Okay, for the first objective, we can identify that the gross rating point of television advertisement in the prime TV broadcast network is a dependent variable. Meanwhile, from the second objective, we can identify that the number of sales over 16 years in the prime TV broadcast network is an independent variable. From this 1 and 2 objective, they have the same type of variable, which is the quantitative variable. It's a discrete variable, and the data was measured on a number of scale with a numerical response resulting from a measurement method. For both first and second objective, the level of measurement is the same, which is the interval data, the most effective scales of measurement that contains a meaningless zero. For first objective, we can identify that the method that we're using is the Pearson's coefficient correlation method, while in the other hand, for the second objective, we use the Pearson coefficient of skewness methods. For our third objective, we use the descriptive statistic and interference statistic for the methods. For the second part of the methodology is the histogram graph. A is a simple histogram graph of TV advertising GRP gross rating point against frequency, while in the other hand, B is a simple histogram graph of sales against frequency. Okay, based on the figure A, we can conclude that the average number of TV advertising gross rating point is 8.5 with the standard deviation of 4.761 and the range of data is 67.550. On top of that, the mode number for the TV advertising gross rating point is 92.898 and the median is 148.1550. Thus, the data distribution is the symmetrical distribution due to the median equals to mean equals to mode. Next, from figure B, we can conclude that the average number of sales is 85%. Moreover, the standard deviation is 4.761 and the range data is 6.48%. In addition, the mode for the number of sales is 11.41% and the median for the number of sales is 15.4750%. Hence, the data distribution is a symmetrical distribution due to mean equals to median equals to mode.
Here is the scatter plot and the frequency table between TV advertising gross rating point and the sale. So the scatter plot showing a positive correlation, and it showed that years when the less gross rating point received, hence the number of sales decreased. Next, moving to the frequency table, the explanatory variable is the gross rating point of television advertisement in the prime TV broadcast network, while on the other hand, the response variable is the number of sales over 16 years in the prime TV broadcast network. The minimum number of TV advertising gross rating point is 92.98, meanwhile, the maximum gross rating point is 190.48. Next, the first quartile of TV advertising gross rating is 123.8925, and the second quartile is 148.1550, and last, the third quartile is 168.4900. The minimum number of sales is 11.41%, while for the maximum number of sales is 17.89%. The first quartile of the number of sales percent is 13.9675%, the second quartile is 15.4750 quotas, and the third quartile is 16.7325%. To sum up, the number of TV advertising gross rating point can impact the number of sales over 16 years in the prime TV broadcast network.
Now I will show the data of our sample, and based on this table, we can see the effect of television advertisement on overall sales at Prime TV broadcast network over a 16-year period from the 2000 until 2015. In this table also, we can see that in years 2008, the Prime TV broadcast network hit the highest level of sales in 16 years, while in 2006 was the lowest level of sales.
Result and interpretation. Interpretation is under the measure of tendency, which is mode, median, and mean. So the first table shown for statistic of TV advertising gross rating point. The mean is 148, median 148, and the mode is 92. Measure of dispersion can be seen on the table, which is the variance is 830.661, range 97.50, and the standard deviation is 28.82120. The next table shown for statistics of sales. The mean is 15.16, median 15.48, mode 11.41. While for the dispersion, the variance is 2.996, range 6.48, and the standard deviation is 1.73082. From this table, we can see that the third objective is answered. Pearson's coefficient of skewness. From the table of box plot below, both of this distribution is skewed to the left.
Based on previous slide, we have achieved the second objective, which is to find the skewness of the two variables between the gross rating point of television advertisement and the number of sales over a 16 years period. Now, I will show you the scatter plot that we have created using the SPSS tools. These results represent the first objective. Based on these results, it proves that the first objective has been answered by using Pearson's coefficient of correlation method. And based on the scatter plot graph of the regression line, this graph shows positive correlation between TV advertising rating point and sales. Now, in this slide, I will talk about the correlation and regression analysis. But first thing first, we will take a look at the correlation table. From the correlation table, the value of Pearson's correlation coefficient R is 0.907. Hence, this value indicates the correlation between two variables as strongly positive linear correlated. For regression analysis, we can see the table based on the model summary. In regression, using coefficient of determination R squared, this result represents the third objective. This also proves that the third objective has been answered by using descriptive and inferential statistics method. From this table also, we can determine the value is 0.822 for the R square. For the comments, we can conclude that 82.2% of variability of TV advertisement can be explained by variability of the sales, while the remaining 17.8% is explained by other factors. Both this table also was carried using SPSS tool. Now we will move to coefficient table under regression. From this table, we can see that the P0 is 7.097 while B1 is 0.054. Both of these values can be substituted into regression equation. Hence, we can let Y equals to sales and let X equals to TV advertisement rating, and this can contribute into the linear regression equation, which is Y equals to 7.097 plus 0.054x. From the regression equation, the slope of the regression line is 0.054, which means that if the rating point of TV advertisement is decreased by 1%, the number of sales also will be decreased by 0.054. Based on this table also, we can determine the idea of scatter plot between the number of these two variables where it's supposed to be positive correlation. As for the comment, we can comment that when TV advertisement increase, the sales value also increase. An example of prediction by using the regression equation can be calculated using the same linear regression equation. For example, the new number of TV advertisement is 150. Hence, we can substitute the new value into the X. So we can get the new amount of sales for the new amount of TV advertisement. That's all for results and interpretations.
Last, we move to conclusion. From this study, we found that the gross rating of television advertisement is independent variable, and the number of sales over 16 years in the Prime TV broadcast network is dependent variable. So this means when the rating of television advertisement increase, the number of sales over 16 years also increase. Now, we move to correlation and regression that we determined using the scatter plot graph. It showed that the rating of television advertisement and the number of sales over 16 years in the Prime TV broadcast network has the positive correlation. Not only that, the data also represent that the data is skewed to the left. To sum up, from this research, there is a direct correlation between the number of sales in the prime TV broadcast network over a 16-year period and the gross rating of television advertising. Television advertising can increase the number of sales because consumers perceive brands that advertise on television as successful and trustworthy brands to purchase. Hence, to maximize the sales impact TV, ads must be a part of a cohesive marketing that reaches consumers across multiple touchpoints.